Hi Chem students, conversions number 4 is now available, as you see, and in this instance I've given you a problem. The problem is about a mineral with a density given to you as 6.637 grams per cubic centimeter. What's the volume of a 327 gram sample of this mineral? So first and foremost, I've kind of hidden in words what the relationship is between whatever we're talking about. So we're not really trying to go from one form of length to another form of length. We're not trying to go from one form of mass to another form of mass. Instead, we're trying to do a conversion from grams, a mass, to a volume, which is going to be in some other unit like milliliters or liters or cubic centimeters. So let's first determine from the question what the relationship is that we have. And it goes like this. All right, first off, we were told there's 6.637 grams of this stuff, and that every time we had that, that's exactly equal to having 1 cubic centimeter. That's what a cc is, a cubic centimeter, centimeter cubed. So we now have our relationship, which is true for any version of this mineral. Now we just have to try to answer our problem. Now some of you are going to be tempted to use, density is equal to mass over volume, and try to use this equation. That's a bad habit to get into. Equations are useful, but what's even more useful is knowing that they're just another way of doing a conversion. So try to do this as a conversion, and you'll have less errors appear as you do problems in your chemistry and physics and math and biology careers. So what are we looking for? The volume. I didn't specify which volume to use. Since I have a relationship that uses centimeters cubed, let's go there. I could have asked for it, though, in milliliters or something else. But we're going to try to get to the number of centimeters cubed. And what we know about this particular example is that there's 327 grams. And now we can just use our relationship and remind ourselves that we need to put, since grams is the 327 grams, that gram is, in essence, over 1, so it's in the numerator. That means we need to put grams in our conversion in the denominator, 6.637 grams, and that's equal to 1 centimeter cubed. Lo and behold, the grams cancel out, and our centimeters cubed are sitting right there, and our answer would then be 327 divided by 6.637. When I do that math, I get 49.269, but that's too many digits, right? Because we only have, here we have 3 sig figs, and here we have 4 sig figs. When I multiply those together, I have to use the smallest number, that's 3. So I can really only express this answer as 49.3 centimeters cubed. Since I have a short video here, I just want to reiterate how important it is that all these numbers have units and that your answer has units, and that when you do a problem, you circle the answer and let me know what's going on. So some things to remember is that when we set up a problem like this, we're doing our multiplication. We can use a multiplication sign, a times, or a dot, but what we can't use are these railroad tracks that you may have been taught before. Those are not mathematically true, so they don't have any meaning mathematically. So while it's a neat trick, it doesn't really work. It's not true, and it's not professional. So one of the things we'd like for you to be is more professional. So get rid of these things. Don't do those. Get rid of those completely, and try to do these as I'm showing you by writing down one thing and then multiplying by another. Real quickly, I can show you that we could have done this problem with parentheses, and we would say, we're looking for the number of centimeters cubed, and we'd put, just so I can remind myself, 327 grams. I could have put that in parentheses, and then I'm going to put my other ratio in parentheses as well, which is that there's 6.637 grams per centimeter cubed. That would be just fine, because that represents multiplication. This is acceptable, but we don't want to do this railroad track thing here. That's bad. So there you have it.